Okay, page 2, starting with problem number 6, graph the system of linear equations. So a system of linear equations means there's more than one of them. And to graph them just means to graph each individual one. To give the exact solution to the system, we're going to be finding the point where they cross. Now when I look at this, I see a y to the 1 and an x to the 1. These are linear equations. They're going to cross once or everywhere because they might be the same line, or nowhere because they might be parallel. So the first thing I'm going to evaluate is whether these are parallel. I need to see them both in slope-intercept form. It's also my favorite way to graph. So I'm going to try and isolate, I'm going to add 2x to both sides and then divide by 3, so I get 2/3 x plus 3. 2/3 and negative 2/3 are not the same slope, nor are they opposite reciprocals, so they're not perpendicular either. They're just two different numbers, and I don't have to worry too much about parallelism. I just need to find them. So the first line I'll do in red has a y-intercept of -1. When x is 0, y is -1. And then I'm going to go down 2 and over 3. And that should be a shallow, less than 45-degree decreasing line, because the fractional slope here that's less than 1 means it's going to be shallow. So this is just a line. To back it up, I'm going to go left 3 and up 2. Left 3 and up 2. Here I'm going to go down 2 and over 3. All right. This is my first line. Now my second one is going to have a positive slope. So if I trust my math, which I'm going to double check, I added 2x, so that should be a positive slope divided by 3. My intercept is going to be here at 3, and my slope will be up to over 3. Up to over 3. So again, an increasing shallow slope. Left 3, down 2. Oh, look, I found my point by just being very careful with my graph. Left 3, down 2. And here's my other line in my system of equations. So it turns out that my solution to the system is the point -3, 1. So my solution set is the point -3, 1. And I just put it in set notation because my solution is a set of a single point. So it's not an empty set. It's not. It's not infinite solutions that are every point on the line. It's just this one specific input-output pair that makes that true. So the system is. The question is dependent or independent. So dependent would mean that one line depends on the other. They are the same line. These are not. They are independent lines. They are not in any way really linked, except by that one point that they share. Nothing else is the same about them. This system is consistent or inconsistent, so the system can be solved. It is a consistent system because the point actually exists. An inconsistent system means parallel. Dependent means same line. So if it's not the same line and it's not parallel, then it's independent and consistent. Show by substitution whether the point 0, 2 is a solution of the system. When they say substitution, they mean x is 0, y is 2. So I'm just going to substitute in for these values. My y, negative y is 2, plus 7 times 0, minus 0.5, is that less than 0? The question stands, right? We're looking to see whether it's a solution or not. It needs to match both of them. I need both inequalities to be true for this to be a system solution. So I'm going to simplify, that's 0. Negative 2 minus 0.5 is negative 2.5 is in fact less than 0. That is true. Now I'm going to substitute into the other one to check whether it makes a true statement. 2 is less than or equal to 2 times 0 plus 1.5. Well, that goes away as 0, right? And the question is 2 less than or equal to 1.5? 2 is not less than or equal to. That would have to be to the left of, and it is not less than 1.5. Since this is false, it is not a solution. So careful substitution into both inequalities checks whether it's a solution to the system of inequalities. It has to meet both requirements to be a solution. Meaning one is not enough. Solve graphically for where g of x equals f of x and label the solutions. So graphically means I'm going to plot these. This one's an absolute value function, and this one's just the line y equals x. I'm going to plot the line y equals x first because that's easy, right? For every, I'm just going at a 45-degree angle through every 1, 1, negative 1, negative 1, negative 2, all the points that are along that diagonal where y is x. For however much I go over, I go up the same amount. Slope is 1, right? Now solving graphically, I do need to solve this absolute value function. So I'm going to evaluate it from a transformations perspective, and I'm going to find the vertex of it, which will be where x minus 2 equals 0, and that'll be at x equals 2. So I've shifted to the right by 2. But then I've also shifted up by 4. So my vertex is here at 2, 4. Now I'm opening down. So I will in fact cross this, but I'm opening down with a slope of negative 3. Slope of 3 and negative 3. My slopes are 3 and negative 3. That is steep. So my slope of positive 3 is happening in this direction, right? I'm not going to go above. There's not going to be any function up here because I know this opens down. So if I go down 3 and over 1, down 3 and over the other way 1, that's going to be my v. Down 3 and over 1 again, down 3 and over 1 again. This is how a straight line absolute value function is graphed, the same slope every time. Now some of you started doing this for quadratics, and that's not okay because quadratic equations don't have linear slopes, so they won't be straight lines. They're going to change their slope each set of points that we graph. So this is where we're at, and it looks like we have one solution that is at 1, 1. So the vertex, I did this, was 2, 4, and the slopes are negative 3 and 3, opens down. Does it have 1, 0, 1, or 2 solutions? Well, it has a solution everywhere it crosses. So there are 2 solutions to this system. This is a non-linear system with an absolute value and a line. To be a linear system, it has to be 2 lines. So does right, one of the solutions is, so if I'm going to make my solution set, it's going to be 1, 1. The other one, I don't know what it is. It's going to be somewhere between 2 and 3. And it's going to be the y value somewhere between 2 and 3. So not knowing exactly where that is, I might have to solve algebraically. I would do that by saying the output of this function needs to be equal to the output of this function. So I'm going to say x is equal to negative 3 times the absolute value of x minus 2 plus 4. Now algebraically solve an absolute value. I need to isolate the absolute value. So I've got x minus 4 equals negative 3 absolute value of x minus 2, and then divide by negative 3, so negative 1/3 x plus 4/3 equals absolute value of x minus 2. So now I can split this into the two equations. One is going to be just as it is, taking away the absolute value symbol. So negative 1/3 x plus 4/3 equals x minus 2. And I can solve this by adding 2. I get negative 1/3 x. Oh, actually, I have to subtract the x as well. I'm going to try and get the x's alone. Actually, I'll add the 1/3 x over here and add the 2 over here. So 2 and 4/3 is actually 3 and 1/3 if I'm going to add mixed number-wise. 3 and 1/3 doesn't feel right yet. I'm not done. Okay. I'm going to, actually, so then, since I'm not done, I'm not going to be mixed numbering. I'm going to add 2, which is 6/3, so I'll have 10/3. Now, I'm going to add a third x here, so that's going to be 1 and a third, or 4/3 x here. Now, to undo this, I'm going to multiply by the reciprocal, 3/4, so that my 3/3 cancels and my 4/4 cancels. Times 3/4, my 3's cancel, and I get that x equals 10/4. 10/4 is 2 and 2.5? Yeah, 10/4 is 5/2, 2.5. So 2.5 is my x coordinate. Great, that's lovely. Now the other equation, so that's my x coordinate, 2.5. I need to find the y, or actually the other one would have led to a 1. So I don't even have to solve the other one, but the other one I would basically take this away, x minus 2, and make this negative. Right? So the two solutions to an absolute value equation are positive thing equals the thing inside, or negative thing equals the thing inside, because the absolute value will have wiped out that negative. In any case, I just need to find the y. So I'm going to go back to, well, the original equation. One of them was that y equals x. So 2.5 must also be, to be on this line, it must be x comma y, where they are the same value. So this is my full solution set found graphically, but then I had to find it algebraically because the point was hovering in space. Okay, I'll make a video for the next page.